All right, today we're going to be talking about an intro to quadratic graphs. So there's a lot of terminology, so make sure you pause this, get all this information written down. And of course, I love to color coordinate, so. But let's go ahead and let's get started. Parts of a parabola, that's how you say that. Parts of a parabola is a graph of a quadratic equation is called a parabola, and standard form of a quadratic function is f of x equals ax squared plus bx plus c. So this should look familiar when we were doing our factoring. If a is positive, the parabola opens up and it goes and it looks like that, and it has a minimum. The minimum would be that bottom point. If a is negative, the parabola goes down like that, and it has a maximum, which would be that point right there. X-intercepts are points on the x-axis. So the y is 0, you're looking for x, and the y is 0. And they're also called zeros, roots, solutions. These are all different ways to do x-intercepts. And then y-intercept is a point on the y-axis. So if you look here, I color-coded all this stuff. So the x-intercepts we said are right here and right here. It's where it crosses the x-axis. And like I said, they're called root zero solutions. The y-intercept is where it crosses the y-axis. So that would be your point there. So x is 0, y, or it would be a b value for your linear equations. Your parabola is the shape. And that's not a very parabola-like shape, but this is your standard form for a parabola equation. There's also something called an axis of symmetry. So it's a vertical line. So your equation is going to be x equals wherever it crosses the x-axis. So if you're to look here, your axis of symmetry, you see this little dashed line on your graph, and you notice it evenly divides the parabola in half. So both sides will be symmetric, meaning they're mirror images, and the axis of symmetry falls exactly halfway between the x-intercepts. So if you've noticed, I've got 2 here and 2 there, so this falls directly in the middle, and that is called your axis of symmetry. You'll see me write it as AOS, axis of symmetry. All right, you also have a vertex point. For your vertex point, there's a maximum and minimum, point xy for the parabola, and if you look here on your graph, the vertex is right here. And in this case, since your parabola opens up, it's going to be a minimum for here. But the vertex is either very top or the very bottom point. Your domain are your x values. So you'll look at your x values here for your domain. And then your range are all your y values, which would be right here. So for your domain, your x values, you are going to write an inequality of negative infinity is less than x, which is less than positive infinity. So it's basically saying that it's going to be between those as an interval of negative infinity, comma, positive infinity. Your range, like we said, runs the y coordinate of the vertex. And again, if it opens up like this, your inequality is going to be y is greater than or equal to whatever the number it is, and the interval is here. So that's a bracket. That means you include that point if there is a point there, and then it goes to infinity. So here, it would be like from here to there to there. If the parabola goes down, it has an inequality of y is less than or equal to, which makes sense because it'll be going below that number. And it's an interval of negative infinity up to that point right here, which would be that number. All right, a lot of information. Please make sure you get it written down. All right, now let's go ahead and let's start looking at some of this information. For number 1, I already plotted the axis of symmetry, and that equation is x equals -1. Now your vertex, I didn't put the vertex in, your vertex is going to be right here. At that point, that's the most bottom point of your parabola. And the vertex I have as this point, which would be -1, comma, -8. And since it opens up, this is the lowest point of your parabola. It's a minimum. All right, the x-intercepts, zoom in a little bit more. The x-intercepts are going to be wherever it crosses the x-axis. And then here we had -3, 0, and 1, 0. So those would be the roots, the zeros, the solutions. And your y-intercept is right here. And yes, I know there's axis of symmetry is off to the side, but this is actually your y-axis right here. And then your y-axis, this point crosses the y-axis at 0, -6. Now, for your domain, you're going to look at your x values. So domain, you're looking left to right. And then as you're looking left to right, this is going to be continuing on forever and ever and ever. Oops, sorry, I'm going to curve it a little. It's technically curving forever and ever and ever that way. And this is going to go forever and ever that way. So that's why we're saying the domain is going to be -infinity to +infinity. Now your range, you're going to look at your y. And then, or I shouldn't say y-axis, excuse me. Just look at your y. And then your domain, you're looking at your x's. All right, so for the range, we're looking here, okay? So from here, the bottom point is -8, and then it's going to go all the way from -8 up to +infinity. And we include -8 because that's the actual point there. We keep this rounded because it's a constant and it's continuing on. All right, I want you to go ahead and try that one. And then now we're going to do axis of symmetry. I mentioned the axis of symmetry in number 1. Now let's find what the actual is if we don't have a graph. So to find the x value of the axis of symmetry, you're going to do -b over 2a. And that should look kind of familiar because you had something with the quadratic formula where x is equal to -b, and then you had a whole bunch of the discriminant, then it was all over 2a. So in your example, you have this. And you should know a is the coefficient of x squared, b is the coefficient of 4, and c is the constant. And all you're going to do is you're going to take your -b value, or b, make it negative, and then you're going to put that as 2 over your a. And then in this case, it'd be -1, so your axis of symmetry is at -1. Now once you know your axis of symmetry is -1, now we're going to plug -1 back into your original equation and find the y value. Then, once you got both, put them together, and that's your vertex. So let's look at this example here that I did for you. So we have f of x is 2 or equals 2x squared minus 8x minus 10. So again, we're going to take this formula right here to find our axis of symmetry, and we're going to go -b over 2a. So your -b would be right here. Well, if it's a -b, you get +8. And then here you have 2 times 2, which gives you 4. And then go ahead and simplify it. So you would write the axis of symmetry, that would actually be x equals 2. So it crosses the x-axis at 2. Now, take this value, and wherever you see x here, you're plugging it in or substituting that value into here. And then once you solve it, go ahead solve it, and you'll get y equals -18, and that's your y value. That's your vertex. So you do axis of symmetry, then plug that x value into your equation to find the vertex. Go ahead, try this one. And now let's go ahead to find our x and y intercepts. So to find the x-intercepts, you're going to set the equation equal to 0 and solve for x using any method that you've learned before. And then to find the y-intercept, you're going to make x equals 0 into the quadratic function and solve. So this is the c value, which is your constant in the standard form of the quadratic function. So I did the work here. And also too, if this helps you, I like to make a little table. Whoops. So if you're looking for y, that's your y-intercept. If you're looking for x, that's your x-intercept. So if that helps you remember what you're actually looking for. All right, so go ahead. First, what we did was we set this equal to 0. So we made that 0. And then we factored our GCF is 2, took that out. And then now we're going to take this and break it up and do our grouping. So when you factor this, you're going to get 2 times x minus 5 times x plus 1. And then now here, you're setting everything equal to 0. Well, we did 2 equals 0, we did this equals 0, and we did this. But if you look at this, 2 or 0 does not equal 2. So we can't use this one. This would be no, because that would not make sense to have that, because 0 does not equal 2. So now let's look at the other ones. So for the other ones, and I'll kind of, there you go, leave it like that. All right, for the other ones, then you have x equals 5, or x minus 5 equals 0, solve for that, x equals 5. And then for the other factor here, set that equal to 0, and then solve for x, and you get x equals -1. So those are your x-intercepts, are this answer and this answer, so that's where it crosses the x-axis. And then the y-intercept is really easy. If it's in standard form, just look at the c value, and then you write it as an ordered pair. So that would be -10 here. And then for your ordered pairs, it would be 5, 0, or -1, 0 for your x-intercepts. All right, go ahead. You're going to try that one. And then now let's start looking at these. All right, so for end behavior, how you read this is as x approaches -infinity, that's what that says, y approaches what? So what you want to do here is look at the arrows on the end of your parabola. What direction is it going as far as the end game of this? So when you look here, these arrows are saying as x approaches -infinity, well, these are your negatives going out this way, then y is going to continue going up, which makes it a positive infinity. And then as x is approaching positive infinity, y also is increasing with positive infinity. So you're just looking to see what directions are going, and then that will tell you that one. So for this one, again, look at your arrows. As the x values are increasing, this is showing that it's going to, your y's are going to become more negative. And then over here, as positive x's, so this are your positive x's, you're looking to see, well, that's also going to -infinity. So make sure you get this copied down. And then here we have functions increasing based on the x coordinate of the vertex. So you want to make sure you're going left to right, and I like to think of this as like a little roller coaster. So let's look at this first one. I drew the axis of symmetry just so that way you could see looking on this. So when you're looking at this, we're going left to right. So when we go left to right, we're going down, which would be decreasing. And we came from -infinity. This is continuing, it's constant, so we're keeping this curved. And then it stops right here at -1, and we include that point, so that's why we do the bracket. And then, as we're going left to right, we notice it's increasing this way. So we started at -1, and we're including that, so that's why we have the bracket. And then it's continuing on to positive infinity. And since it's constant, that's why we keep it, I put not included, but think of it as constant movement. So it hasn't stopped. So that's why we keep going there. All right, so go ahead. I want you to try this, and you're looking at your axis of symmetry as kind of like your midway point. All right. So finish that one. All right, and then for this part, it says the function is positive, which means it's above the x-axis, or negative, which means below based on the x-intercepts. So I like to think of this as like a submarine going either above or below the x-axis. So if you're looking at your x-axis, think of where you're here, it's above. From your x-axis, from this point on, it's above. So what we did here, that would be your positive. So it's above from negative infinity to -3. And then this means that it's also, that it's a second part included. So from here is here. And then from here to there, you've got 1 to positive infinity. And this part is where it's also above. Now for negative, you're looking for what's below the x-axis. So from here to here is below. So that's your x values are from -3 to -1. And you write that there. All right, go ahead and you're going to try this one. And then that's it for today. It was a lot of information. Make sure you get this all copied down. And then, of course, we'll go over everything that we need to in class.